My name is Nikita Grebnev, and today I'm covering the first assignment of the Data Manipulation Techniques course. Today's topic is a little heavy, because it concerns both health issues and personal life issues of Canada's citizens, but it's hard to come by an easier theme when you're looking for the government data. For some reason, it's filled with murder, rape, poverty, and death, and I guess compared to that, it's a much safer topic to talk about. Today, we're going to be looking at data taken by surveys and unified under the theme of work absence. It was collected by the organization that comes by the name Statistics Canada, and it covers the amount of days lost by incidence rate, how often people take days off, by inactivity rate, how long those breaks were, and by total days lost in a year. Each grouping is also separated into smaller groups, specifying whether it was because of health issues and disability or personal and family issues. However, it wasn't a single data source. Each time such surveys were collected, people also specified their age group, their sex, their union coverage, how permanent their job was, and the size of the establishment they worked in. There were also such questions as geography, STEM jobs, tenure, occupation, public and private sector, and many more. But those will not be covered here, or else I would finish this assignment in April. Unfortunately, they chose to separate the data they collected into various CSV files, each containing data on some individual questions. So you can have the file for age groups, for union coverage, and for everything else, but not for everything at once. And the nature of service is such that those variables are independent. You cannot assume that if a person is in their 50s, they would have union coverage, for example. And that means that every data set had to be treated manually and individually. And oh boy, was that a chore. I quickly realized that my PC will explode if I try to do it all in Excel. Either that or my head will. So I moved on to SQL. I personally have a decent amount of experience using MySQL in particular, so I ended up using a web-hosted MySQL database service. This allowed for two things: using DataGrip, an application that allows you to modify databases using SQL, and an easier connection to Tableau, since it already has a way to tune into existing databases. I imported the CSVs directly into my new database and started treating the data. First, I didn't need any columns that people who worked on it before me left for the data visualization. I'm not sure what they were using, but it seems to be some sort of a vector graphical engine, since there were a lot of pre-plotted points for graphs inside of these CSV files. Then, since the ID for the survey was the same for each record, and all records were collected in Canada, I removed those columns as well. What I was left with were a bunch of records for each year, and that had to be fixed. For my visualization, I needed each year to have only one record, so I transposed the table. This way, instead of having it so that each category in the year had its own record, I ended up having one record for each year, and things like total incidence rate or inactivity rate, illness or disability would become fields in these records. Finally, since the only two criteria present in each set of data were sex and year when the survey took place, I used year as a unifying table to connect every dataset for Tableau. I also removed things like sex, union coverage, and age groups into separate tables, and then connected those to the tables where I left the statistics, neatly tidying up everything in the database. Here you can see part of the code I wrote for that. These separate tables became dictionaries for my statistics. On this screenshot, you can see the four main tables on the bottom and supporting tables on top. And neat it was until I connected to Tableau. Tableau met my efforts of having everything in order with blatant disregard, and insisted that I cannot connect both year and sex to each dataset, despite it being logical. So I only connected the year and then quadrupled the sex table, ending up in a very sexy dataset. Then I connected remaining supporting tables that would serve as dictionaries, since in each dataset I would leave only the IDs of the age groups, union coverage, job permanency, and establishment sites. And types of those categories would remain in respective dictionaries. Once that conundrum was sorted out, I could finally begin the visualization of my fine comp data. First of all, I was curious about the distribution of the days spent off work by various age groups and reasons for why they would take their days off. In case of illness, it was quite predictable. The older the person was, the more likely they would fall ill, and I know that feeling very well, even though I'm only 26. 10 years ago I could party all night and then go to school, and now I can strain my back if I sit uncomfortably for too long. The other reason was family and personal issues, and that was more interesting in my opinion. I believe that the wider distribution in the younger age groups is showing people taking different decisions with their life before settling in with their families. For example, the youngest group on the far left is either doesn't take days off at all or takes them fairly regularly. We could presume that this is due to some young adults taking the time off work to support their parents or other elderly relatives. But as we ascend through the ages, the distribution becomes narrower, and the median amount grows taller. This might be either because people in that age have more responsibilities regarding their families, or they start to value their personal and family issues more. In either case, it was a good sign. These are the sorts of data we could expect from the real population, and that meant that the surveys were somewhat close. More out of curiosity, I also checked the distribution between men and women. And in this graph, this data is showing that women tend to take more days off, both due to personal issues and due to illnesses. I would like to be honest and say that this was expected. We still have this toxic masculinity that tells us to be brave and carry on, sometimes overruling the common sense that we need to take a break every so often and see our life from a different angle. That also corresponds with a shorter life expectancy for men, not just in Canada, but as a common thing. Now, being confident in my data, I started looking further into the problem. First real question that I posed was whether the unionizing and increase in workforce awareness of their job affected the frequency and length of breaks people take from their work. And the result was inconclusive. Yes, the incident rate grew slowly over the last 20 years, yet the peaks and lows among the unionized people and non-unionized people were correlated, meaning that unions had no mischievous plan to make everyone a striker. Also, despite women taking days off more often in general, there wasn't any significant increase or decrease when divided by sex. Seeing that, I decided to check each other factor in the provided datasets. And what I really wanted to see is whether there are any trends along which different groups of people were moving. What affected people more? Their age, type of their job, size of their establishment, or maybe unions? And what I found was most curious. At first glance, the graphs shown here might seem pretty unrelated, but it finally allowed us to see the effects of each separate factor. Here, on the top left graph, we can see that people in unions not only are more confident to take days off, but also slowly taking more and more each year. Same with the job permanency on the top right. Each year people take more time off if they have a job security, and this amount grows much faster than with the ones who don't. However, this was to be expected. After all, job security is quite important, and it does become more and more important along the years. What I didn't expect was how little impact the establishment size had. First, graphs for any kind of establishment were pretty close, and second, their growth was very similar as well. The age groups, on the other hand, brought more curious data. Let's see the individual age groups along the years. Yes, the older people get, the more time they take off, and yes, pretty much every line is parallel to the others. Until we reach a group of elderly people aged 65 years and more. What in the heavens is this, and why is it here? Starting from basically nothing in 1997, it grows sporadically through the first decade, and continues growing through the second decade, a little more steadily. This could indicate a multitude of things, and we need to dig deeper to find out what it means. Maybe people start settling down later in their life, and start to pursue their career later in their life. Maybe they are more convinced in the economy and their future, or maybe they fear losing their income. Maybe people simply begin to care less about their health, or maybe people begin to care more about their families and personal life. These trends show interesting possibilities and raise questions, but I don't think that with the data at hand these questions can be answered. As any other topic, this needs more research. One thing is for sure, these trends definitely show the aging of Canada's workforce, as such a spike in the last 20 years can only be explained by an increase in the age group overall. When more people work more during their lifespan, of course, they would take more days off. I would like to thank you for taking this dive with me, and also I would like to thank all the people that collected this data. Here, in the end of the presentation, you can find all the sources I used, and on that website there are even more surveys concerning other vital topics of the Canada's labor market. The MySQL web service I use is called Kamatera, and it should be available with the credentials I attached to this assignment. And in this file you can find the Tableau's story with the graphs I showed here. Thank you again for watching, and goodbye.